Welcome to the seventh annual UC Davis Grad Slam event via Zoom. I'm JP Delplanque, the Vice Provost and Dean of Graduate Studies. Thank you for joining us today for the UC Davis final round. Grad Slam is a system-wide competition that challenges grad students to summarize countless hours of academic research and discovery and present it in under just 3 minutes. This is one of our favorite events of the year as it allows us to highlight some of the most exciting graduate student research taking place at UC Davis. Take, for instance, recent PhD alumna Katie Murphy. Her presentation on genetically modified corn won the grand prize at the UC final round in 2019. Though this year's virtual Grad Slam looks a bit different from the competition in previous years, we are so pleased to be able to host this competition. And it's been incredible to see how well our students have innovated and adapted to the virtual format. In February, a team of judges from across the campus narrowed down all our qualifying round videos to identify the top 10. And now we have the great pleasure to see the final presentations today. But before we begin, just a couple of Zoom housekeeping notes. This event is being held in Zoom webinar format, which means that audience members do not have video or mic abilities. Should you have any questions throughout, please feel free to post them in the Q&A feature. And you can also cheer on the finalists in the chat feature. To make sure you can see all of the screen and all of us on the screen, you can change the setting from standard to side-by-side gallery view in the top right corner of your screen. Now, it is my pleasure to introduce the finalists. You can actually switch your camera on so we can see all of you. Thank you. Abigail Nissen, PhD student in biomedical engineering. Maybe you want to wave or something. Venice Brown, PhD student in integrative pathobiology. Lindsay Cameron, PhD student in neuroscience. Amelia Munson, PhD student in animal behavior. Samantha Worth, PhD student in animal biology. Paul Kassensap, PhD student in horticulture and agronomy. Chelsea Kellen, PhD student in immunology. Spencer Dahl, PhD student in chemical engineering. Alia Skawara, PhD student in psychology. Lisette Navarrete, EDD student in educational leadership in the Kendall program. Welcome to all our contestants. We had 5 highly esteemed judges who assisted in determining our winners. Please join me in thanking them for their time and effort. Jacob Cadiz manages SMUD Community Education and Technology Center, which helps promote sustainable practices and technologies for a zero carbon future. Jacob's background is in public engagement and sustainable communities. He combined his MBA studies at the University of the Pacific with 2 years as a Peace Corps volunteer in Paraguay. He has a passion for partnering with community organizations on creative ways to lift up our region. Thank you, Jacob. Ebony Harper is the director of California Transcends, a statewide initiative that works to promote the health and wellness of transgender people across the state of California. She has a long history of making a difference and advocating for marginalized communities, and she advocates at both the local and national level for trans and human rights, gender, climate, and disability justice, and race equity. Among her many distinctions, Harper has most recently been recognized by the California legislature as District 7th 2021's Woman of the Year. Congratulations, Ebony. Laura Lindenfeld is the executive director of the Alan Alda Center for Communicating Science. She's also the vice provost for academic and strategic planning and a professor in the School of Journalism at Stony Brook University. She holds a PhD in cultural studies from UC Davis and serves on our graduate studies advisory board. As a communication researcher, her work draws inspiration from the idea that we can make better, more informed decisions about how we shape our collective future. Stacy Muse is the Director of Engagement for Public Scholarship and Engagement, and she is responsible for developing, supporting, and strengthening mutually beneficial relationships between the community and campus. Dr. Muse brings over 15 years of experience in the nonprofit and education sectors, building strategic partnerships for public good. Sansire Tonsel is an Emmy Award-winning reporter at Fox 40 News. Her long history as an investigative journalist has taken her around the world and has earned her an Edward R. Murrow Award for Excellence in Broadcast Journalism. And lastly, I would like to thank our Grad Slam sponsors, as without them, we would not be able to conduct this event. Please join me in thanking the Office of Research, Public Sponsorship and Engagement, and Global Affairs for their support. The students will be competing for the following prizes: Public Scholarship and Engagement, it's a $500 prize. People's Choice Award, which you all will have a chance to vote on at the end of the presentation, that's $500. Third place, $750. Second place, $1,500. And the first place winner will receive $2,500, and of course, a seat at the UC system-wide final round on May 7th. Now, without further ado, let's start with our first presenter. There was a random drawing, and the lucky first student is Abby Neeson.
Wouldn't it be nice to live forever? Unfortunately, our bodies can't keep up, especially our joints. The harsh reality is that even as you sit here, a young, healthy, 20-something-year-old grad student, the chances that you will develop knee osteoarthritis are 1 in 3. Osteoarthritis is a disease that develops with age, as the natural lubrication in the joint wears away, leaving a painful bone-on-bone grinding, and it's especially common in the knee joint. It's so common, in fact, that every year 1 million Americans get a knee replacement, where the joint surface is replaced with metal implants. This surgery was developed over 50 years ago. But here's the kicker. What if I told you that 20% of patients still have pain and are not satisfied after their surgery? My name's Abby Neeson, and as a biomedical engineer, I work with both surgeons and engineers who've developed a revolutionary new knee replacement technique. Our technique uses your individual knee anatomy to align the implants, such that your knee is restored to its healthy pre-arthritic state. Now, wait a minute. You're probably thinking, isn't that what surgeons already do? But it's not. The majority of surgeons use a technique called neutral alignment. And in a side-by-side comparison, you can see that for individual alignment, the knee alignment may be slightly bowed, depending on what's normal for you. Whereas in neutral alignment, the knee is aligned to be completely straight. This straight alignment developed with the notion that it would preserve implant longevity, but it comes at a significant cost, the cost of patient satisfaction. So we have two needs then, implant longevity and patient satisfaction. And my research is looking to meet both of these needs. To do so, I need to demonstrate that individual alignment preserves implant longevity just as well as neutral alignment. So when I talk about implant longevity, I'm specifically talking about the bond between the implant and the shin bone. Because if this bond were to fail, then the replaced knee will fail. To study this bond, I analyze special x-rays which are taken of patients on the day of their surgery and at time points after their surgery. These images allow me to track the motion which occurs between the implant and the shin bone. Now, these motions are very, very small. In fact, they're called micromotions because they're less than 1 millimeter. But these micromotions are indicative of whether that bond has failed. By studying these micromotions, I can determine whether individual alignment preserves implant longevity to ensure the best possible knee replacement for everyone. Thank you.
So Abby, you received your bachelor's degree in civil engineering, studying the mechanics of structures. What inspired you to study orthopedic biomechanics? Can you explain that transition?
Yeah, so I actually get that question quite a bit. Most people look at the two fields and think they're totally unrelated. And so I guess it really goes back to when I started rock climbing, which I picked up as a hobby after college. I was working in industry as a civil engineer. And for anyone that's not familiar with rock climbing, it's basically you trying to balance yourself on very small holds and not fall off. So you're super aware of, where your hands are placed and trying to maintain tension throughout your body. And so it really sort of shifted my perspective in starting to see the human body as a type of structure that's going to be subjected to sort of the same loading, stresses that we would, analyze in larger structures. And so with that sort of revelation, I was like, this sounds like a really cool field to get into. If I can take my technical mechanics background, analyzing large structures, and apply that to the human body, that would just be amazing. And so I, at a pretty young age, just decided to apply to grad programs that were focused on biomechanics and orthopedics. And it was a good choice.
Clearly. So you mentioned you're a rock climber. Where do you like to climb?
So I guess there's two of my favorite gyms that I kind of switch between. So in Davis, the local gym is Rocknasium. And then sometimes I'll also venture into Sacramento and climb at the Boulder Field.
Oh, okay. Do you have a role model, like a climber you particularly look up to?
Honestly, I wouldn't know who to say. I do sometimes watch the like world championships, but I don't really have a role model now.
Okay. To prepare for your grad slam presentation, I know you attended a few Grad Pathways Institute workshops. Was there any particular tip or workshop that you found most helpful that helped you prepare?
Yeah, definitely. So I really am appreciative for the Grad Pathways workshops. And I would say that the most helpful tip, which kind of seems, it seems like you would know it, but I guess going into grad school, I just was oblivious, was that you really want to shift your perspective as the speaker to, what the perspective of your audience members is going to be. And so trying to understand what they might know / not know about your topic, and then kind of build upon that to structure your talk and make sure that you're catering to what your audience would need to know, and what the most important thing to them is, so that they actually want to listen to you. So I would say that when I first started giving presentations in school, you're in a classroom with kids your same age, everyone has the same knowledge. And so going into industry and grad school, where you're presenting to a very diverse types of audiences, you really need to take that into consideration.
Right. Yeah, that makes plenty of sense. Thank you, Abby, and thank you for your presentation.
Thank you.
We're now moving on to our next presenter, Venice Brown. Venice.
$20,000. We take roughly 20,000 breaths a day, from mothballs, cigarette smoke, car exhaust, and wildfire smoke. If you recognize the smells of any of these that I have listed, then you have been exposed to a small and simple chemical known as naphthalene. This toxic chemical is extremely abundant in our environment, especially in urban areas. There has been vast research in characterizing naphthalene, and many have concluded that long-term exposure can lead to lung damage and the increased risk of developing lung cancer. So imagine being able to give your lung a cloak of protection by just eating lunch. It may sound far-fetched, but what if I told you that the answer to all your lung health problems may be found in mushrooms? Scientists have found a unique mushroom compound that has a wide variety of health benefits. We believe that it's able to hunt down and bind to harmful chemicals found throughout our body. Some scientists call it the new super antioxidant. Blueberries are old news. Once digested, this super antioxidant will circulate throughout the body, getting absorbed in various organs and tissues. Then the protection begins, which brings me to my research topic. I am interested in using this super antioxidant to fight against naphthalene toxicity in the lungs. In addition, I'm curious to see how this protection will vary amongst different ages, as current research do show that as you age, your natural antioxidants grow weak, being in great need of a little boost. All of this is extremely exciting because my research will be the first to test this mushroom super antioxidant against lung-damaging chemicals such as naphthalene. The research that I have conducted has shown that this super antioxidant can protect the lungs from various doses of naphthalene, in addition to boosting the immune system and cell healing productivity. How does it work? We don't exactly know the specifics, but what we do know is that it's able to detoxify and protect the lungs from naphthalene exposure, basically slowing down the development of lung disease. However, with all this said, more work still needs to be done, but the possibilities are endless. So I will leave you with this. What we eat makes a huge difference to our lung health in the long run. We breathe 20,000 breaths a day. Let's protect our lungs with the simple task of adding mushrooms to the menu. Thank you.
Hi, Venice.
Hi.
Presentation.
Thank you.
So what initially attracted you to your research in pulmonary toxicology?
Yeah, so in my undergraduate, I worked in an environmental virology lab. And so kind of having that environmental theme, I switched, and now in grad school, I worked in environmental toxicology. The pulmonary side, on a personal level, I have asthma, and so much pollution, especially in Southern California, in the air that caused my asthma. And so I feel like it's very important to understand what's in our air and improve how we breathe and our quality of life in the long run.
Right, yeah. Is there a particular mentor that you think about that's helped you, or maybe multiple mentors?
Yes, oh, absolutely. Multiple mentors all the way here. I wouldn't be here without all of them, and it's too many to thank, but currently I would have to thank my PI, Dr. Laura Van Winkle, for inspiring me and encouraging me to participate in Grad Slam. I kind of came in as a very shy and introverted first year grad student, and so here I am presenting the top finalist. So this is amazing.
All right, yeah. Do you, so you mentioned cooking, and I know, I've been told that you like to cook. Are there some of your favorite things to cook? And I'm taking notes, I'm taking recipes down, so go ahead.
Well, yeah, so both of my parents are Jamaican, so Jamaican cuisines are my go-to. I do enjoy cooking all types of food and learning all types of food. Gordon Ramsay is my inspiration one day, but that's just what I do on the side, besides research.
Yeah, he can be intense though, okay.
Very entertaining.
Right. Well, thank you so much, Venice.
Yes, thank you.
We're now going to go to the next speaker, Lindsay Cameron. Lindsay, when you're ready.
Everyone here knows someone that suffers from depression. It's a common and crippling disorder that affects about 1 in 5 people. Current medications are inadequate. So inadequate that suicide rates across the country have increased and now surpass the total number of deaths caused by car crashes. Not to mention, the number of depression-related diagnoses has skyrocketed since the start of COVID-19. The CDC has referred to this as a mental health crisis. It's time to start treating depression effectively. For my PhD, I vowed to find a way to better treat this devastating illness. So first, let's talk about why current medications are so inadequate. There are 2 main reasons. The first is that it takes on average 6 weeks for these drugs to start working, leaving no therapeutic options for those that are severely depressed or suicidal. The second reason is that over 30% of patients are treatment resistant, meaning they don't respond to any of the medications on the market. Now, part of this problem stems from the fact that these drugs were invented decades ago, before scientists really understood how depression worked in the brain. But now, after these decades of research, we have a much better understanding of what's going on, and therefore we can develop better therapeutics. And this is what brings me to talking about psychedelics. You've probably heard about them in the media, things like LSD, MDMA, or magic mushrooms. These drugs have been tested in human clinical trials and have been shown to rapidly reduce depression within hours, and they work in treatment-resistant populations. They work by strengthening the parts of the brain responsible for motivation and achieving your goals and focus, and dampening down other parts of the brain responsible for fear or depressive thoughts. Now, as promising as these drugs might be, they're still hallucinogenic, which means they're still dangerous. And with the prevalence of depression across the country, we can't exactly have all these people going around tripping on LSD. So, what I wanted to know is, do you actually need hallucinations in order to have a therapeutic effect? In other words, could you make a non-hallucinogenic version of a psychedelic? This is exactly what I did for my PhD. We made a library of compounds of non-hallucinogenic psychedelic analogs and tested them side by side their hallucinogenic counterparts. We found they both worked equally as well and rapidly after treating. And sometimes the non-hallucinogenic version actually worked better. It's time to start treating depression effectively, and I am changing the way that we can do this, so we can all get the happiness that we deserve.
Hello, Lindsay.
Hi, how are you?
Good. Great presentation. Fascinating, actually, this foray in psychedelics and what you did. What attracted you to this field? I mean, you got into it a little bit in the presentation. I'm wondering if you can elaborate on it.
Yeah, well, there's two reasons for me. One is that just the importance of mental health. We don't have very good drugs for treating depression currently, and there haven't been new drugs developed for almost 50 years. And it's really the foundation on which your life is built. So it affects your work, your relationships with your family and friends, even how you wake up in the morning. And so it's really important that people have a good mental health foundation in order to really live their lives the best way. The second reason is much more of a scientific one. Psychedelics from a scientific point of view are fascinating. They are some of the most powerful drugs that humans know about, but we know almost nothing about them. It's been really hard to study these drugs because of all the legal restrictions, but our lab here at UC Davis is one of the only labs in the country that has a license to study these drugs and do this kind of work. And they've had really profound effects in terms of helping people with mental health. And a single dose can even help relieve depression for years or a lifetime, and no one knows how they work. So the first part of my PhD was understanding how they work, and the second part was making them better.
Well, but maybe I have an add-on question here. Do you have a sense, or it's probably difficult, but what about the legal framework that you alluded to, right? So now that you've made these discoveries, what is the likelihood? How long is it going to take, do you think, for some of these drugs to come to market?
Well, they're already patented. We're already doing some more drugs. They're not in humans yet, but they're headed that way.
Oh, okay, all right, that's promising. So this is your second time in the campus Grad Slam. So you're in a unique position to tell us how different this is this time around. What was your biggest surprise?
I guess my answer is also two answers. The first is that it's pre-recorded and it's not live, and that's really interesting because you don't have when you do the in-person presentations, you can't just start over if you go overtime, but you can do that on the pre-recorded versions. So you can really make sure that you're within the time limits, and if there's something you don't like about your presentation, you can just redo it. So you can really kind of fine-tune your presentation in a way that you can't in the live version. The Second biggest thing is that there's no audience. And this was really difficult for me. It's probably good for people if you have like stage fright or people make you nervous, but I really thrive off the energy of people and presenting to people and kind of reading the crowd. And when you're, in your bedroom and talking to a computer screen and you're all alone, it's really difficult to read the crowd. And when you pause for dramatic effect, is it working? Because you don't really know, you can't see anybody. So for me, I think it was more difficult, but yeah, it really emphasizes that this year it's more about refining the elevator pitch rather than public speaking.
Yeah. I think you probably have seen the late night comedians trying to do it without an audience and the difficulty of that. I'm sure you can relate. You mentioned that you would like to live in a jungle. Which jungle?
Any jungle. I really love the outdoors. I love backpacking, climbing mountains, hiking. That's kind of my way of refreshing and my way of maintaining my mental health. And I'm really not picky. I love being outside, and any jungle would do the trick for me.
Okay. All right. Well, thank you so much for answering the questions, and we'll see you a little bit later.
Thank you.
Our next speaker is Amelia Monson.
All of my favorite stories about me from childhood involve some amount of danger. They're the times when I fell out of a treehouse and then got right back up again. And I like these stories so much because these are the moments that made me, the resilient adult that I am today. And I think this is a pretty common narrative, but interestingly, it's not the logic that we use when we're tasked with taking care of some of nature's most valuable babies, endangered wild animals. Take salmon, for example. When humans raise these culturally and economically significant fish, we raise them in very sheltered hatcheries, and then we release them into the wild where they have to deal with real predators that want to kill them. And importantly, captive raised salmon have lower survival compared to wild-born individuals. The question that has driven my dissertation is whether or not there are experiences that we could give fish that would make them better at dealing with challenges as adults. To answer this question, I worked with Western mosquito fish that I brought into the lab, bred, and then exposed to different challenges. So I have this top red group that were exposed to changing temperatures, this blue group that were exposed to the very scary scent of largemouth bass, the purple group that got both stressors, and then the golden group down at the bottom that didn't have to deal with anything stressful while growing up. And then I looked at them all as adults, and some of the effects are apparent just by looking at them. You'll notice my two middle groups, the blue and purple ones, who were both exposed to predators during development, grew up to be smaller, which is fascinating, right? Because smaller fish, less appetizing to a predator. But I actually cared less about what they looked like and more about who they were. Basically, I wanted to give my fish a BuzzFeed-style personality quiz, but tailored towards fish. So I took them all and I put them into new novel tanks that were safe and looked at their behavior. Interestingly, the fish that were exposed to both stressors, that purple group, were more active during these pulses of safety, suggesting they would be able to gather resources that they could use during future challenges. But the most interesting thing to me is that any type of developmental stress resulted in adults that were more behaviorally consistent. And this is fascinating because consistency is a general pattern of behavior that we see in most wild fish populations that helps them to coordinate group behavior and do other anti-predator defensive moves. It seems like developmental stress is crucial into making a fish behave like a fish. My Western mosquito fish are a great reminder that what doesn't kill you doesn't just make you stronger, it makes you normal. Thank you so much for listening.
Hello, Amelia. Nice Nietzsche quote at the end there. So talking about fish, right? Is there a favorite fun fact that you have about fish? Maybe not favorite, but the one that comes to mind.
Oh, there's so many.
I was thinking about this, that I recently had a surgery, and when I was a surgery where I was like under, but I don't remember anything.
Mm.
And when I came to, all of the nurses came in and they were like, "Oh yeah, you're the fish girl. We learned a lot about fish during your surgery." So apparently even unconscious Amelia wants to share some fun fish facts. I think my favorite one, I mean, mosquito fish are the best fish, but another fish that I've worked with that I really love are a species of cichlid that do mouth brooding. So the mother lays the eggs, the father puts sperm on them, and then she turns around, takes her little fins and pulls the eggs into her mouth and raises those eggs in her mouth for a period of around 2 weeks. So during that time, she has caviar in her mouth and she doesn't eat nothing. She keeps gargling them. It keeps them from getting infected. It protects them from predators. And actually, even after they have hatched, she will let them swim around. But if she senses anything that's dangerous, she like magic school buses, opens her mouth, and the babies all swim right back inside. Which, like, this level of just like care that parents provide for their offspring is something that I think we just don't understand that fish do, but it's totally fascinating.
I had never heard that. And, you know, I was actually fascinated when you talked about the conceiving a personality test for fish. I mean, that kind of caught my imagination too. And so I'd like to know also a question I asked before, actually, but it's an important one for all grad students, about a mentor that has played an important role for you.
Oh, I mean, so many. I think like, I mean, I was lucky that I had a mom and a dad who were both like very, like they would have mouth brewed me all they could have. So like they introduced me to science and like asking questions about the world really young. And so I think that was really powerful for me. But also, I mean, my advisor here has been incredible, Andy C. My undergrad advisor was the one who really introduced me to how cool fish are and not just how cool animals are. I've also had mentors who've helped me really come into my own as a teacher while here at Davis, and also just all of the people who've supported me as a human. So I think one of the things I love most about Davis is the community of people that we're surrounded by who can mentor you in everything from academics to just staying sane.
Right. That has been challenged with the remote operations that we have now. So the sooner we can get back to something more in person, the better. You're also, this is also your second time participating, right? So what was your biggest surprise? And you can't keep the same answer.
Oh, I mean, I think that like, I mean, it happened, right? I was supposed to do this last year, and it was right around the time that isolation happened. And so I was gearing up to like get on stage. I was all excited. I had bought myself a new like beautiful blue shirt I was very excited to wear. And then it never ended up happening. So I think the biggest change is just that I got to do it, which I've been very excited about. But I also, in some ways, like, I miss having an audience, and it's unfortunate that we're not in person, but there's definite benefits to this. Like my parents were able to come today. Hi, Mom and Dad. And the fact that they're here getting to see all of this has been so great. And I mean, my dog is like in my lap and he wouldn't have been able to be in my lap at the actual talk. So it's been a good day.
Yeah. Well, thank you so much, Amelia.
Thank you.
Our next speaker is Samantha Worth.
To eat meat or not to eat meat? That is the question. Whether 'tis more sustainable to consume the plant-based meat alternatives of today or to continue on as humans have for centuries. Okay, that's not what Shakespeare's Hamlet said, but this concept of the sustainability of the meat we choose to eat has become a topic of increasing importance in our modern society. But what is sustainability? My research defines sustainability with 3 pillars: the environment, the economy, and society. Meat alternatives such as Impossible Burger and Beyond Burger have been described as more sustainable substitutes to ground beef. But this is largely based on comparisons of their environmental impacts. So to gain a better understanding of the sustainability of these products, my research has considered both the economic and environmental impacts of replacing ground beef with these meat alternatives in the US. From this work, we found that ground beef contributes to less than 1% of the entire US economy. So replacing ground beef with meat alternatives doesn't actually lead to a shift in the broader economy. It does, however, result in a reduction in cattle production. Now, cattle production supports a large segment of US labor, from the ranchers who raise the animals to the essential workers who bring the cattle from the fields to our dinner plates. So this reduction in cattle production leads to a reduction in labor, meaning a loss in US jobs. When we now consider the environmental impacts of replacing ground beef with meat alternatives, surprisingly, we find an increase in land use. While a reduction in ground beef does mean less land is used directly for cattle, more than 40% of this land is too poor in quality to be used for any other purpose. So an increase in meat alternatives means an increase in agricultural land use. Another surprising result we find is an increase in greenhouse gas emissions. While cattle often get a bad rap for their methane emitting burps, meat alternative production is more fossil fuel intensive, meaning it has a greater impact on our climate long term. So, to eat meat or not to eat meat? The answer may, in fact, be both. My research has highlighted that there are a lot of trade-offs to consider when deciding whether to eat ground beef or meat alternatives. And with a growing global population, our focus shouldn't be on either or. It should be on how can we produce more of both sustainably. That way, there's room for all at our growing tables.
Hello, Samantha.
Hi.
That was a fascinating talk. We went from Nietzsche with the previous one to Shakespeare. I mean, you explained really well the source of your research, what it leads to, and what we learn about meat eating as a society. I'm wondering what attracted you to livestock production as a field, right, before you got into it.
Yeah, so I get that question a lot, and I'm a San Diego native, never had any background in agriculture prior to coming to UC Davis. But I got here and I took a class in undergrad from my current boss, Dr. Frank Mitlerner. In one of his lectures, he talked about the 2050 challenge. So this idea that by 2050, we need to feed 9 billion people. And we need to do it with either the same amount of resources we have today or even less, because we also need more land for more people. So this kind of posed this big challenge in my mind where I'm like, well, how do we do that? What can we do? And my other animal science classes kind of taught me how advanced the US is with livestock production, meaning that we are really good at producing a lot with very little input. So I kind of got interested from there in this idea of like, okay, how do we bring this to the rest of the world? How can we produce food sustainably and feed this growing population? That's been kind of my primary motivation running through.
Well, yeah, thank you. That's some insight there. I asked this question before, and like I said, I think it's an important one. That's a question about mentoring and the mentorship that you've received. And if you can point to one or several mentors that have helped you become, the researcher that you are right now.
I would echo my colleagues here today that it truly takes a village to get where we are today in our PhDs. And there are so many people who have been just completely invaluable to the process for me. But I would say my primary mentor is my PI, Dr. Mitlerner. He has been just my rock throughout this whole graduate process. He's such a great instructor, great mentor, and he's a really, really great speaker. So that's been something that's been really great for my graduate career and getting me interested in communicating our research, is that he just has such a passion and an excitement for what we do that it's hard not to get excited about the work we do.
Right. I understand that you're in the middle of writing your dissertation. Is that correct? Yeah.
Yeah.
So in the limited free time that you have, what do you do? What do you enjoy doing to relax from that?
I mean, I guess it's a weird time right now with COVID and everything. So my activities are even further limited, but mostly if I'm not at home working, I'm at my local gym working out or coaching. I coach workout classes a few times a week. And if I'm not doing that, I'm hanging out with my housemates, walking their dogs and just trying to be outside as much as possible.
Yeah, I think dog walking has seen a huge spike over the past year.
Oh yeah, yeah.
Well, thank you, Samantha.
Thank you.
Our next speaker is Paul Kasemsat.
Let's start with a game. Can you please help me name all the tasty food that we can make from these golden wheat grains? Bread, pasta, pizza, noodles, cake, cookies, donuts, pie, a lot of different pies, and so much more. Globally, these tiny grains provide 1 out of 5 of all the protein and calories we eat every day. But the future of wheat is at risk. My name is Paul. I'm a plant scientist on a mission to save our food from climate change. As the level of the major greenhouse gas called carbon dioxide goes up, we observe wheat protein going down. Wheat makes protein from N, a nutrient called nitrogen that farmers add into the soil. I study nitrogen, and my doctoral research is Mission Impossible. Welcome to my office. Among these plants is where I work. If I could talk to my plants, hey, what form of nitrogen would you all like for lunch today? Ammonium or nitrate? The first lesson I learned, plants don't really talk to us. And this is why scientists need to be observant. I rely on visual cues like changes in leaf colors and take measurements like height and weight as indicators of how plants enjoy the nitrogen I provide. I grow my plants under a very high level of carbon dioxide, the same level we expect to breathe in at the end of the century. Under such condition, wheat appetite for different form of nitrogen can change how much protein they make in the grain. My experiment is like a time machine into the future. I search for plants that can make nutritious grain and determine how much nitrogen farmers need in the coming years. If we add too much nitrogen, the leftover can contaminate the environment. But with too little nitrogen, our plants won't grow. We won't have enough food for everyone. Think about the last time that you felt hungry. My research helped the plants and us get ready for the future by figuring out the right plants, the right amount, and the right form of nitrogen that we need to grow our food. Let me end this mission report with the motto from the Food and Agriculture Organization of the United Nations, Fiat Panis, which means let there be bread. Because this mission impossible, should we accomplish it, we make sure we can continue to enjoy tasty, nutritious food made from wheat for the future to come. Thank you for supporting science. Tasty.
Yeah, now I need a snack. Nice presentation, Paul. You clearly explained the impact of your research. I'm wondering if studying plants is something you always wanted to do, or something that you grew into.
I've always been fascinated by plants. Like I like to say, the secret life of plants, because, like I said in my presentation, plants can't talk to us. So it made me curious, like, how are they feeling? How are they doing? And I just love to learn how they respond to different cues. I think the main question that kind of got me into studying plant science was basically how plants use sunlight to turn water, dirt, and air into food. And not to mention, like, we can eat plants. So who wouldn't like to study plants?
Okay, all right. So let me get this right. I think you did your undergrad in Thailand. You did a master's degree, I think, in the Netherlands, and now you're in the United States. what an international experience. How has that impacted your research and you know, more broadly, how has it impacted you, your experience?
I would say I'm really grateful for the opportunity for access to higher education that really allow me to get to experience how plants are being grown and how food is being produced in different parts of the world. It really shaped me on the solution side, because what I learned is that we might have different ways to grow our food, but actually we're working toward the same goal. And as the main problem I try to tackle in my research, climate change and carbon dioxide, the greenhouse gas, don't respect the boundary. They travel everywhere. So everyone will be impacted by this. And especially our fellows in developing countries will be the people who suffer the most. So what I learned is that we need to work together. We rely on each other to find a solution to help address climate change and food security.
Okay. I heard you called yourself friendly neighborhood science storyteller. So I need to hear more about this. What do you do? What does that mean?
Well, as a plant scientist, most of the questions I got was basically like, "Hey, Paul, my plants are dying. Can you save them?" But really, science is for everyone, and I really aspire to be a better science communicator, because to address crisis or global issues like the pandemic or climate change, we scientists can't do it alone. We really need everyone in the audience. We really need everyone to work together, to get on board and help us. So thank you all for supporting science. Thanks for attending today. Today we are hearing great stories from everyone in the panel. So yeah.
Excellent. Thank you, Paul. Our next speaker is Chelsea Kellen. Chelsea.
Halor, rubor, tumor, and dolor. I don't know about you, but my Latin is a little rusty. So in modern terms, this is heat, redness, swelling, and pain. These are considered to be the 4 pillars of inflammation. And once induced within our body, they lead to bone destruction by bone eaters in our fingers, back, knees, legs, and even toes. What am I talking about right now? Well, my name is Chelsea Kellen, and I'm here to talk to you today about the exciting world of arthritis research. We've all heard of arthritis before, be it seeing our grandparents rubbing their knees after a long day, a commercial about the newest painkiller, or even this past year as everyone joked about not having Megan Thee Stallion's knees. My point is we have a basic understanding of this disease, but I bet no one here really knows arthritis. See, arthritis itself is a general term used to describe a plethora of bone and joint diseases that affect over 126 million Americans each year. And it's the leading cause of disability in the United States. Moreover, there's no actual cure for arthritis. Pretty scary, right? Well, the story doesn't end there. Traditionally, we are taught that arthritis is just this unavoidable thing that happens as we age. But the truth is we really don't know what causes arthritis. We do know that bone destruction in arthritis is the result of an imbalance between bone loss by bone-eating cells, known as osteoclasts, and bone formation by bone-building cells. This is where I come in. I perform research on the impact of inflammation on these bone eaters as it relates to arthritis. See, osteoclasts are naturally programmed to eat bone, as this allows for the formation of new, stronger bone. However, in arthritis, the presence of inflammation pushes these osteoclasts into overdrive, and they begin to overeat bone. So why or how does this happen? Through a series of experiments, I have been able to isolate specific factors or chemicals released during inflammation that interact with osteoclasts to not only kickstart the excessive bone-eating activity, but also promote the generation of these bone eaters. Moreover, I have discovered a vicious cycle in which inflammation increases bone eating by osteoclasts, and in the process of eating bone, these osteoclasts release byproducts that then promote continued inflammation, leading to prolonged redness, swelling, and pain. Currently, I'm delving deeper into this cycle. How are these inflammation factors interacting with bone-eating osteoclasts? Does this interaction change anything about the bone eaters? Is it possible to stop this interaction or at least control the bone eating these cells do during inflammation? Answering these questions is imperative. I believe my hard work is enhancing the understanding of how calor, rubor, tumor, and dolor, or heat, redness, swelling, and pain and arthritis leads to bone destruction by these osteoclasts. Thank you for your time.
Hi, Chelsea. So you mentioned that as an undergrad, you took a course on science communication, and I'm wondering if looking back, you can identify things that have helped you in the presentation we just saw, for instance.
Most definitely. So one of the main things we did in that class was whenever we wrote a speech or submitted an outline, she would actually make us draw a picture frame and then divide that picture frame into 3 components: keywords, significance, and conclusion. The goal is it's our job as researchers, presenters, or just speech givers to make sure that we fit whatever our topic of interest is in the context of the bigger picture so we can make a connection with the audience. The idea is once we connect with the audience, we need to make sure that they understand how whatever we're presenting or talking about affects them in their daily life. And if it doesn't currently affect them in their daily life, how will it eventually affect them? And if there's a possibility that it won't directly affect them, how will it affect the people in their circle? And the idea is once they understand this relevance or they see the connections, then they'll be more interested in your work. And once people are more interested in your work, they'll have more of a desire to listen to what you have to say, and they're more likely to talk about your work, which will likely allow for your research or your topic to reach a broader audience then. And that's what I attempted to do today as we talked about osteoclasts and inflammation.
Yeah, very good. That's very insightful. I know you also participated in MCB GAP, so Molecular and Cell Biology Graduate Admission Pathways Program. And I'd like to hear your perspective on how it allowed you to make the connection and create your interest or maybe amplify your interest for going to grad school.
Yeah, so I had already decided in my undergrad career that I wanted to pursue a career in research, and I was looking into immunology because I always had an interest in health sciences, diseases, and things of that sort. UC Davis was already on my radar at that point because they have a great immunology program here. However, I was really worried because I'm originally from Louisiana. So not only was this going to be completely across the country for me, I was also at a relatively small HBCU. So I didn't know how I would be able to really function on this campus that at any given moment in time has thousands of people present. However, coming to that program and doing it basically comforted me in a sense. I realized that UC Davis is a huge school, but they have these smaller pockets of social networks, and that's really where I found my comfort. I was able to talk to Dr. Bevins and Dr. Holm and really find my different segments of people. So I knew if I came out here, I would not only get a great education, but I would also have a really good social environment to continue to grow as a scientist and a person.
Right, right. So picking up on your career plans, you mentioned you wanted to be a researcher. Can you elaborate on that a little? Where do you see what type of, what I mean by what type of research is research in what environment?
So I definitely want to go into academia. My career goal is actually to be a professor and to have and maintain my own research lab in a minority serving institution. I really want to give other undergraduate students the opportunities and experiences that I had so they can learn that research is a viable career option, because I would have never had that experience. I know I would not be at UC Davis right now. Moreover, I want to give them the opportunity to experience research so that way they can build up their CVs so they can be competitive applicants for the UC Davises of the world.
Right. Well, looking forward to that and your contributions to that. Thank you, Chelsea.
Thank you.
Our next speaker is Spencer Dahl.
By the year 2035, General Motors plans to offer only electric vehicles, and Ford is beginning to set similar goals. Can you imagine that? The gas-powered car that you likely drive now will not even be offered by two of the largest producers of automobiles in the US in just 14 years. But is our battery technology really ready for that? Hi, I'm Spencer Dahl, and I'm a PhD student here at UC Davis in the Chemical Engineering Department. And I study what keeps making batteries fail. Why can current electric vehicles only go a few hundred miles? And why does your phone battery always die in the middle of the day? Basically, I'm here to make sure you can stop recharging your phone multiple times a day because it keeps dying from you watching YouTube and TikTok videos. So why are batteries so important? Well, batteries have become very portable over the past few decades, and specifically lithium-ion batteries are already in a number of electronics, like the phone batteries shown on the slide and the newer electric vehicles. But batteries are also a popular energy storage technique for the future, as renewable energies like wind turbines become more efficient and even more widespread. However, we currently have no way to store all that energy that gets produced when it's windy outside. And the reason we can't store that energy is because of all the problems with lithium-ion batteries. So when it's not windy outside, we can't utilize any of that energy that was previously produced. So why can't the battery store that energy? Well, a lithium-ion battery operates by moving the red lithium atoms, shown in the figure, between the positive and negative ends of the battery, which creates a flow of negatively charged particles known as electrons that can power your phone or car. But as this lithium moves from one side to the other, it can create weak points in the structure that allow it to collapse. You can draw some comparisons of the structure of a battery by looking at the wood frame of a house. A house is made up of wood studs that support the structure. But if you were to remove a few studs in an area of the house, you might see the house sag or even collapse on itself. Similarly, in a battery, the lithium acts as the studs for the structure. As you begin to remove those lithium studs, the structure can collapse and not allow the lithium to come back in when the battery is being recharged. Now, my research focuses on solving this problem and making that structure stronger. So I go into the house and I replaced a few of the studs with ones with different materials and see how the strength of the house changes. So just as cartoon character Spencer's doing, I can go into the structure of a battery and replace a few atoms with ones that are larger or smaller or have a different chemical makeup and see how the strength of the structure changes. For example, in my research, I've seen promising results of making the structure stronger by replacing a few of the cobalt atoms in the positive end of the battery with ones like tin and titanium. This research could mean we could fundamentally understand why batteries fail and also how to successfully prevent that in the future. It can mean we can actually reach our goals for climate change, renewable energies that are being set by GM and these other companies, all while keeping your phone charged for those TikTok videos. Thank you.
Hello, Spencer.
Hi.
Hi. I got to say this. What sparked your interest in batteries? Sorry, it's bad.
No worries. Yeah, I mean, kind of as I talked about in my talk, batteries are just so ubiquitous today. Everybody interacts with them on a daily basis, and they have, such power for the future, pun intended, to, really like help our renewable energy future, store these energies for like wind, solar, hydroelectric dams that's, just being wasted when sometimes we can't utilize all of that energy during the day. So if we could actually store this energy, it could mean, we could use it for all of our grid storage here in developed countries, but also be a really useful technique for even developing countries for getting electric power there. So yeah, they're just such like a powerful tool, and it's just exciting to be working on a technology that's so relevant to our near future.
Right. Yeah, I can see that. Can you point to a mentor or a couple of mentors that have supported you along the way?
Yeah, definitely. I mean, so many. My boss at my old job, when I worked in industry, he was an old professor at UC Boulder and really convinced me of like the importance of grad school and how it can help you develop these skills to tackle these really large, complex problems. And my current advisor here at UC Davis, Ricardo Castro, has just been so supportive of kind of all my crazy ideas and things like that, and always so optimistic throughout it. And both of them just really helped me understand the importance of things like this, like research communication, and just like helping people understand the importance of all this research and what it can do for our futures. So yeah, they've been so critical in how far I've come and everyone. So yeah.
Well, talking about communication, I mean, I personally think that this one is the most desirable stage to communicate about science, but I may be alone in this. If you had your pick of a publication, podcast or broadcast even, where you could talk about your research, what would it be? It's not an easy question, actually.
Yeah, I mean, Grad Slam, there you go. This is it. Yeah, so the type of material that I work on are called ceramics, and the American Ceramic Society has a podcast called Ceramic Tech Chat. that would be really interesting to go on and talk about it there. But for the most part, I just love going to conferences that are really multidisciplinary. And, you know, we're approaching this battery problem from more of a material science perspective, but a lot of other people are approaching this problem from a completely different angle. So just getting to go to those conferences and talk with experts in the field about how they're approaching these are always really fun and entertaining.
Yeah, I can see that completely. Thank you, Spencer.
Thank you.
Our next speaker is Alia Sakwara. I'm sorry, Sakwara.
I invite you to take a deep breath. Now, close your eyes and call to mind someone you love. Allow their image to fill your mind. Now turn your attention to something that troubles them, some harm or suffering they may have experienced. Imagine what this suffering is like for them. Moved by the strength of your love for them, wish with all your might that they be free of this suffering. Take a deep breath. Now, turn your attention to someone you don't like so much, someone who has hurt you or who wishes you ill. Allow their image to fill your mind. Now think of something that might be causing them sadness or pain. Imagine what this suffering is like for them. Recognize that they, like you, do not wish to suffer. Moved by this shared desire, wish that they too be free of this suffering. Take a deep breath and open your eyes. How was that for you? If you're like most of us, it was a lot easier for you to wish for the person you love to be free of suffering than it was for the person you don't like. But what if we could wish just as hard for people we don't like as we can for people we love? My name is Alia Sakwara, and I'm a cognitive neuroscientist studying compassion and responses to suffering. In my research, I look at how practices like the compassion meditation we just did can actually change our brains and make it easier for us to care about the well-being of others. I use electrical signals generated by the brain and recorded at the scalp to visualize brain activity at a millisecond by millisecond time scale. Using these tools, I'm examining whether, with practice, the brain states we generate when we imagine people we don't like can become more similar to the brain states we generate when we imagine people we love. Our brains are incredibly flexible. We learn new skills all the time. Just like riding a bike or playing the piano, compassion is a skill that can be practiced and learned. In a world of 7.8 billion people, where our climate, our ecological systems, our viruses don't respect borders, this ability to extend our circle of care isn't a feel-good gimmick. It is a foundational skill for our collective survival. Thank you.
Hello, Alia.
Hello.
Sorry, I tripped up on your name there.
It's a tough one.
There's something fascinating to me in the topic you study, because I'm wondering, how do you pick this as a topic? I mean, it's both an obvious topic in a way, right? I mean,
yeah.
and yet it puzzles me, how you came to that. Can you get us?
Yeah, how do you land on that? I mean, honestly, it comes from my own tender heart. I, growing up was constantly overwhelmed by the amount of suffering in the world. And as I got older, you become more and more attuned to the many diverse kinds of suffering, whether it's relational or someone's individual struggles within themselves, or the huge systemic inequalities we see globally and within our own country. And reflecting on all of this, I started thinking, well, what is it? What is like a leverage point that could actually influence all these diverse forms and provide hopefully some amelioration? And what I came to is like, if we could capitalize on this really beautiful human ability to care for others, so easy to care for our parents, to care for our children. And if we could find a way to extend this ability to care, it would be a lot easier to start to face these collective challenges that we all have. So obviously it's not the only ingredient, but for me, it feels like a really fundamental one.
Okay, yeah, that makes sense. Your presentation has received the Global Education for All designation. So I got to ask how you see yourself applying that research globally.
Absolutely. So I was so honored to receive that, because that's a huge piece that I'm really hoping to work towards in my career and in the service that I hope to provide. So in terms of the approach, there's so much that we know about how to build and cultivate compassion that isn't broadly or effectively applied yet. So one piece is working with experts and communities in more specific areas to start to apply what is already known. And that has to be a bi-directional conversation. So also learning from those groups about how these things work in the world. So I currently have a collaboration with faculty at the law school, Raquel Adanya, and at the med school, Dr. Koga, where we're working on bridging the legal scientific gap in immigration cases. And that's an area that I personally really care about. So in terms of the specific subject areas, I'm really hoping to start to work in the areas of global migration and conflict transformation, which I feel like are hand in hand.
Mm-hmm. Right. That makes sense. You, I believe your undergraduate degree is in theater?
It is.
Right. So, I mean, to many people, I think that's going to seem pretty distant from cognitive neuroscience. And so I'm interested in the differences. I'm interested in the commonality that you see between the two also.
Yeah, absolutely. My first instinct when I hear that question is like, they're not different. And I think that that's because for me, the motivating core question has always been, what is it like to experience the world through someone else's eyes or in someone else's shoes? And so the methods are just very different. In theater, you're using character studies and text analysis and putting on performances for building empathy and for this kind of catharsis. And then in cognitive neuroscience, I'm looking at people's brain waves and working on building tractable research questions. So the methods and how I spend my time day to day are quite different, but the motivating core questions for me have always been the same.
All right. Yeah, excellent. Thank you so much.
Thank you.
Our next speaker is Lisette Navarrete.
Older, underrepresented, non-traditional. Why do we give students these labels, and how do we expect them to succeed with such unwelcoming designations? One population of current and prospective students that's too large, too diverse, and too important to ignore is adult learners, especially at California's community colleges, the very colleges that serve over 70% of public higher education students. So who are adult learners? Well, it turns out that many of them share one characteristic. They are trying to balance school and work. And I don't mean work as in a fancy internship. I mean work for shelter, to put food on the table, often for children of their own. Unfortunately, traditional pathways to a degree are not designed for students who don't fit a specific mold. That's why I'm asking California's community colleges to begin adulting, to more intentionally focus on working adult students, those 25 and older who work more than part-time. Nationally, 80% of community college students work, and 64% of California students say that balancing school and work is their primary obstacle to success. My research at the UC Davis School of Education builds on over 50 years of student retention and persistence studies. It deviates from the notion that a student should adapt to its college and instead suggests that a college adapt to its students. My three-part study, first, builds a profile of working adult students at California's community colleges by looking at economic and enrollment data. Second, I explore how welcoming and receptive colleges are to this growing population through a document analysis. And finally, I hear directly from students to understand their experiences and to hear how the college may have helped or hindered their success. My study encourages colleges and state leaders to recognize that we simply can't leave working learners behind. Not as California faces a 1.1 million degree shortage of individuals ready to take on the new jobs created by the changing economy, and definitely not as we grapple with the consequences of the pandemic and its inequitable recovery that's leaving the poor further behind. It's time to begin adulting and to intentionally focus on adult learners, those who need us most. Thank you.
Hello, Lisette.
Hi, good afternoon.
There you go. So I got to ask a similar question that I've asked before, because it's actually, in my view, one of the most difficult things that a graduate student has to, doctoral student has to do, is to identify their research topic. So I'm interested, I mean, you made very clear the importance of your topic. I'm interested in how you formulated it. How did you end up formulating it?
Thank you. Thank you for the question. As a first generation student, I've seen many individuals with educational goals and aspirations that have been let down by inflexible institutions. And when I got to grad school, I noticed that what happened when you got to these advanced degree areas is that pathways were structured for you. They were flexible on your work schedule. They recognized that work was not an unfortunate distraction, but instead it was a basic necessity, especially for students of color. And I began wondering why the same thing, I'm in Candel, we meet on Saturdays, I adapt to my work schedule, why that wasn't happening in lower division and in undergraduate education, where we arguably educate more individuals than we do in any other levels of education. And I wanted to learn more about this population and think about what we could do to better help Californians, students of color, and those that had a dream that had been let down.
Okay, yeah, thank you. So you're currently enrolled in our ADD program, but your undergraduate degree is from UC Riverside. So in your heart of hearts, and that's not a trick question, you consider yourself an Aggie or Highlander? I have an additional question. Why is the Highlander the mascot for UC Riverside? But
this is like asking me to choose my favorite child or favorite parent.
Sophie's choice.
I bleed blue and gold. I think the University of California is such a treasure to this great state. That's such a hard decision. So I think I'm going to create my own new term that captures my intersectionality, and I call it an Aggie-lander. So that'll be my own special badge of honor that I wear. I couldn't be where I was without my undergraduate education. And I have a lot of dreams that my education and the opportunities at UC Davis, I believe, will make possible. So tough choice, tough question.
Yeah, really good answer though. So in addition to being a graduate student, you're also the Vice Chancellor for Finance and Facilities Planning for the California Community Colleges. If you could propose one collaboration, you can propose more than one, between the community colleges and the UC, what would it be? What would they be?
I have two key ideas of where the University of California and California community colleges can partner. One, thankfully, is already well underway and advancing. The first is research. I think one great example of research that is happening is the Wheelhouse Center for Community College Leadership and Research. This allows us to have a great partnership where we can elevate data that helps us co-collaborate on student success. And it focuses on a system that's large, but doesn't get a lot of attention in research. But there's a lot riding on it, especially when you think about our economy and the well-being of Californians. The second, I think, is a very critical area of partnership. It's around clear transfer pathways, again, particularly for students of color. There are 6.8 million Californians with a high school diploma and no degree. And further, there are 3.5 million Californians with some college and no degree. if we partner around transfer, UC and CSU can be an unstoppable force that can tackle our social and economic challenges that this state and nation faces.
Right. I agree with that. Thank you so much, Lisette.
Thank you.
Okay, that was our last speaker. And so thank you to our contestant for sharing your research with us. We're now going to open the voting for the People's Choice. Please visit the link on the slide that you see right here, or better yet, use your phone to capture the QR code to vote. We'll leave voting open until 2:20. That's a little short. We probably should leave it up a little bit longer than 2:20 because it is 2:20. So let's say for the next, 10 minutes? And then while people vote, we will take questions from the audience for our students. Okay, let's say 2:25. I got my producer here telling me 2:25. So you'll have until 2:25 to vote for People's Choice. So do it quickly. And in the meantime, we're going to take questions for the audience for our students. Please put your questions in the Q&A section below, and then we'll start answering them. Oh, our students will start answering them. All right, so for all the finalists, what is the hardest part about participating in Grad Slam? And what was the most valuable, rewarding part? So, yeah, go ahead. Go ahead, Ellie.
Little hit at that. I would say the hardest part for me was that it was recorded. I definitely would have preferred it being in person with a physical audience. It's just more fun to get that engagement, even though I'm sure I would have gone overtime in that environment, but it would have been a fun challenge. And I think the most rewarding part for me was that I spent a lot of time talking with my friends and family in more detail about my research than I probably ever have, in order to kind of figure out how best to communicate to a broader audience. And it was just, it's really nice to have that kind of engagement with the people I love in my life and really like get their feedback on what I've been doing for the last 6 years.
All right. I think I had Aliyah and then Ebony.
I have almost nothing to add to that. That's kind of what I was going to say. You know, one of the hardest things for me was really battling perfectionism, since you can record it, like when to say, okay, you know what, we're done. This is good enough. But it was just incredibly rewarding to get to talk to, like Samantha said, friends and family, and really feel the support of that larger community that isn't just your lab or your research group. I'm gonna have the chance to share something that, you know, we all spend so much of our lives on, that we're so passionate about, in this way that hopefully can connect and you know, land for more people. And that's just such an amazing gift.
Right, right. Anyone else wants to chime in? No? Okay. I have a question for Venice. I mean, somebody does. Do all mushrooms have this super chemical or just specific ones?
Yeah, so the chemical's name is actually ergothioneine. It's a long title, or ET. And yeah, all mushrooms have it. Some vegetables and beans have it, but mushrooms have it 12-fold. It does range between the mushrooms. Any mushrooms origin from Asia will have the most. Personally, I love king oyster mushrooms. They're delicious. They're a great meat substitute as well because they're so like fibery. So I highly suggest, like, it just has so much ergothioneine. It's so healthy for you. Yeah.
Thank you. A question for Amelia. What do you mean by fish that act more normal after facing developmental stress? What does their consistent behavior look like?
That's a great question. And something I wanted to talk about. I feel like the 3 minutes is always hard. There's always more you so this is one of these fun things that we have found, not just in fish, but in many, I think basically every animal species we've looked at. They have this characteristic that we sort of colloquially call personality, which is that there's variation between how animals act, but there's consistency within an individual. So everything from like primates and elephants down to crickets and spiders and fish and all of those, we see that in most behaviors that you look at, if you ask a bunch of animals, what do you want to do? They vary. They vary in how active they are. They vary in how much time they want to spend with other fish or other animals. I'm just always a little fish focused. But within an individual, they're very consistent. If this one fish wants to spend time with other fish, it wants to spend time with other fish right now and in the future and in the past. And that means that individuals are different, which has all of these really interesting consequences. But it turns out that my research is suggesting that if a fish doesn't experience these challenges early on, they tend to be less predictable later on. So as an adult, today they want to play with you, tomorrow they don't, and you can never predict what they want to do because they're all over the place, which makes coordinating group behavior hard. It makes a lot of sort of anti-predator type things challenging. And we think there's a lot of really good benefits to being a reliable individual that they miss out on if they're not having these experiences early in life.
Oh, okay. Thank you, Amelia. A question for all of you, and that question we could be on for like the next 2 days. What is the biggest challenge to conducting your research? Whoever wants to start.
I can start. So I would say one of the biggest challenges with my research, and one of the reasons that inspired me to do this competition, was that I actually am the one that's cold calling all of these patients and asking them if they want to join my research study. So knowing that was incredibly overwhelming. And just, I am not a salesperson. I was, out of my comfort zone, but it really inspired me to think about, how can I communicate what my research is doing and the goal of my research in order to be a good recruiter for my study and, have patients want to join. And so I think that this competition has been really helpful in helping me clarify how to talk about my research to a general audience.
All right, excellent. Thank you, Abby. Somebody else wants to chime in?
I guess for me, a general blockade in my research is just time. Arthritis is not something that happens overnight. So especially when you try to replicate it, one trial can take anywhere from 3 to 6 weeks alone, and then you have to process that and then redo it a second time. But it's definitely like a labor of love. I'm definitely a time will pass anyway type person. It's just sometimes I wish it's like, oh, come on, little buddy, turn red. But, it is what it is.
Right. Thank you. I have another question for Venice. When it comes to preventing the next potential pandemic or dealing with airborne pathogens, do you believe the things we eat can help with prevention?
Yes, absolutely. The things you eat are so important, what you put in your body. A recent paper, it's a review paper, actually came out that believes that ergothioneine, or the mushroom antioxidant, could actually work as a all-natural treatment against COVID. And I know COVID's still new. We're all still learning a lot about this virus and this pandemic. But I thought that was very fascinating. And it just proves once again that what you eat every day, add fruits, add vegetables, take your vitamins, every little bit helps. Drink lots of water, all these little things. It's super important to your health in the long run.
Okay, thank you. We're gonna take, until 2:30 as a break. You can relax, switch off your cameras, and then we'll reconvene here at 2:30. Thank you, everyone. All right, welcome back, everyone. And I want to thank you all for attending our 7th annual Grad Slam. And thank you again to our contestants, judges and sponsors, along with our Grad Slam committee for the production of this virtual event. And there was a lot of work going on in the background, so too many names to name them, but it was really teamwork. We have a video message from Joanna Regulska. She's the Vice Provost and Dean of Global Affairs and she wants to congratulate the 3 individuals who received the Global Aggie designation. The Global Education for All Prize recognizes a Grad Slam submission that illustrates how a graduate student embraces global learning. Additionally, the finalists will have the opportunity to have their video showcased at the Global Learning Conference hosted by the Global Learning Hub in Global Affairs in April of this year.
Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Joanna Regulska, and I'm the Vice Provost and Dean of Global Affairs, and also a faculty member in the Department of Gender, Sexuality, and Women's Studies here at UC Davis. I'm so inspired in hearing about such incredible research from our graduate and professional students, all in under 3 minutes. With that said, I promise to be very brief in my remarks. First and foremost, congratulations to the top 10 finalists in this Grad Slam competition. It's clear your leadership and your projects are making a difference in solving some of the world's most prevalent challenges. On behalf of Global Affairs, I'm thrilled to highlight 3 students who receive our Global Aggie designation. These students' presentations align well with our deep commitment to social, racial, and environmental justice and an engagement with the UN Sustainable Development Goals. So first, Paul Kasemsab's presentation covered global challenges such as hunger, nutrition, and climate change in ways that also reinforce the humanistic elements and the global and local impacts of such a research. Congratulations, Paul. Lisette Navarrette's presentation delves into a global topic near and dear to our hearts, quality education, and does so in ways that encourage us all to consider the power imbalances in the field and how to address them. Congratulations, Lisette. And the third, Ali Squaquara's presentation complements some of our UC Davis global learning outcomes so well, including the critical importance of developing cultural humility, self-reflection, and empathy. Congratulations, Ali. Congratulations and thank you to all the presenters for contributing so much to UC Davis and to the world by sharing your expertise, your experiences, and perspectives. Thank you also so much to Dean Jean-Pierre Deplanque and the entire graduate studies team for hosting this wonderful learning experience for us all. Best wishes to everyone participating in this exciting competition.
And many thanks to Dean and Vice Chancellor Regulska for her partnership. So now, the moment that we all have been waiting for, the announcement of the winners. We're going to start with our Public Scholarship and Engagement Prize. It's a prize of $500, and it goes to Paul Kassensab. Congratulations, Paul. Our next prize is the People's Choice, the one that you all voted on today. 360 votes. The attendance was amazing today, so this is outstanding. The price is $500, and it goes to Chelsea Kellen. Now, our third place winner with a price of $750 is Aliyah Sukawa. I didn't do too well either here, but congratulations, Aliyah.
Thank you.
Our second place winner and with a prize of $1,500, Paul Kassensab. And now the Grad Slam final winner with a prize of $2,500, and we'll also be going on to the UCOP championship. Amelia Munson.
Thank you.
We didn't have a drum roll, so congratulations.
Thank you so much.
Well, congratulations to all our winners, all the competitors. It has been, from my perspective anyway, a wonderful event. Please virtually join us to cheer on our UC Davis champion at the UCY Grad Slam competition. It will be Friday, May 7th. You can join us at gradslam.universityofcalifornia.edu. You see that on the slide down here. Thank you again for attending the UC Davis 2021 Grad Slam. Take care of yourselves. Bye.